Okay, pre-cal students, let's go ahead and finish this review sheet. My voice is pretty rough today, so I'm going to talk pretty quietly. We're dealing with page 667, and let's go ahead and get started. Okay, here we go. We're going to find the other 5 trig or the other 4 trig function values, and we're going to do that by using trig identities. Now, notice that the sine of x gives you a positive 3/5 and the cosine of x gives you a positive 4/5. Okay, so with that in mind, I know that I'm in quadrant number 1. Okay, because in quadrant number 1, that's where sine and cosine are both positive. Okay, now having said that, let's go ahead and list out all of our trig functions here. Okay, so sine of x, cosine of x, tangent of x, cosecant of x, secant of x, and cotangent of x. Now, because we know we're in the first quadrant, then we know all of our answers will be positive. Okay, and here we go. Sine of x is 3/5, and the cosine of x is 4/5. So I know that cosecant of x will be 5/3, and the secant of x will be 5/4. Okay, now tangent of x. Tangent of x equals sine over cosine. Okay, now having said that, if I take 3/5 divided by 4/5, I will get 3/4. So the tangent of x is 3/4, and so the cotangent would then be 4/3. Okay, 4/3. All right, let's move on to number 9. Now remember, on your trig identity sheets, we know that the sine of 90 minus an angle, we'll call it theta, is the same thing as the the cosine of that angle. These are called cofunction identities. Okay, there are reciprocal identities. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals, but they're also cofunction identities. Cofunction. Well, sine and cosine are cofunction identities. Cosecant and secant are cofunction identities, and tangent and cotangent are cofunction. Okay, so cofunction identities, you can always write a trig identity like this using your cofunction identities. Okay, so sine of 90 minus an angle equals cosine of that angle, or you could say cosine cosine of 90 minus that angle equals sine of that angle. And you could do this same thing with secant and cosecant, or cosecant and secant. And you could do the same thing with tangent and cotangent, or cotangent and tangent. Okay, so right off the bat, we know right away that if I have sine of 90 minus an angle x, that's the exact same thing as just saying cosine of x equals square root of 2/2. So notice right here at the very beginning that when I take sine of an angle, I get a negative number, and when I take cosine of an angle, I get a positive number. A lot of you are forgetting to get your positives and negatives correct. Okay, so right away, make sure you know what quadrant you're in. You want to go to a quadrant where sine gives you out a negative answer and cosine gives you out a positive answer. That's the 4th quadrant. The 4th. And the sine sequence there is negative, positive, negative, sine, cosine, tangent. So with that in mind, I'm going to put sine, cosine, tangent, and then I'm going to put this. Right away, students, put your signs. A negative answer, a positive answer, a negative. And then, of course, the reciprocal functions are the same. So if sine is negative, cosecant is negative. If cosine is positive, then secant is positive. And if tangent is negative, then cotangent is negative. Now, here we go. We know that cosine is square root of 2/2, and we know sine is square root of 2/2. So So the reciprocal over here would be 2 over square root of 2. And if you rationalize, you will get this. You will get 2 square root of 2 over 2. Okay? Now when that happens, notice your 2's will cancel. Okay? So really what you're left with over here is negative square root of 2. Now if I flipped this and I got this, then obviously if I flip the exact same thing here, I'll get the exact same thing over here. So, except the sign will be different. So here I'll have square root of 2. Now, let's try to figure out tangent real quick here, okay? Now, the tangent of x, as we know, is sine over cosine. And notice, students, I really didn't worry about the signs like positive and negative because I already know my answer for tangent is going to be negative anyways, okay? So, tangent is sine over cosine. And look, if you have a million over a million, it's 1. So if I have square root of 2 over 2 all over square root of 2 over 2, that's going to be 1. So there we go. Now the reciprocal of 1 is just 1. So there we go. This really isn't too difficult of a problem to do. Okay, these are really simple. Okay, let's take a look at number 11. Now the directions for 11 say to simplify this problem as far as we can go. Okay, so here we go. Let's go ahead and try to do this. Okay, now students, for me, the first thing I notice is I have a cotangent squared, okay? And if I have a cotangent squared, I think of my Pythagorean identity that says this right here. So the Pythagorean identity I think of right away, students, is 1 plus cotangent squared x equals cosecant squared. Now, I have cotangent squared x plus 1. So really, for this right here, I can put cosecant squared x. Now, students, think about this. 1 over cosecant squared is the same thing as just sine squared, the reciprocal. And so there we go. We simplified it down to sine squared, okay? All right, let's move on to number 17, okay? Now again, I'm seeing all of these squareds here, so I'm thinking right away we're probably going to use a Pythagorean identity, okay? But first of all, factoring sometimes helps, okay? And I notice both of these terms have a cosine squared. So I'm going to pull cosine squared out of both of these. And when I do that, I'm left with 1 plus cotangent squared. Okay? Pretty simple. Now, let's go back to our last problem here. Remember, 1 plus cotangent is cosecant, okay? So I'm going to put cosecant squared. So now I'll have cosine squared. And then here I'll have, and what was it again? It was cosecant squared. Cosecant squared. Now, what else could I do here? Well, guys, think about it. Cosecant squared. Now watch this. Cosine squared over 1 times 1 over sine squared. Like that. Because why would I do that? Well, I'm going to show you why in a second. But cosecant squared is the same thing as 1 over sine squared. And now multiply these together and you get cosine squared over sine squared. Now why would I do this? Because we have a trig identity. It's called a quotient identity, okay? And it says cosine over sine is cotangent. So cosine squared over sine squared would be cotangent squared x. There we go. We simplified it all the way down, okay? All right, number 21. Now here, we're going to want to get a common denominator and put these two fractions together. Okay, so very quickly here, let's create a little bit of space here. All right, there we go. And there we go. Now, and here we go. So we're going to multiply this fraction here by cosecant theta cosecant theta minus 1 over cosecant theta minus 1. Okay? And we're going to multiply this fraction here by cosecant theta plus 1 over cosecant theta plus 1. And the reason is that will give me now a common denominator of cosecant theta minus 1 times cosecant theta plus 1. Okay, so here we go. Multiply this times the 1, and I get cosecant theta minus 1 over cosecant theta minus 1 times cosecant theta plus 1. Okay? Minus, and now we take this times 1, and we'll get cosecant theta plus 1 over, and then I'm going to take cosecant theta minus 1 times cosecant theta plus 1, and I'll get the same denominator, which was my goal in the first place, okay? So we'll pull this right over here, okay? And now let's continue on. Now, the whole reason I got a common denominator was to put my two fractions together, right? So, I have cosecant. Now watch this carefully, students, okay? I have cosecant theta minus 1 minus cosecant minus 1. So, really what I have is minus cosecant minus cosecant, so they cancel. And then negative 1 minus 1, it's a negative 2. So I have negative 2 over this right here, okay? Now, we're almost done, but think about this. If I multiply these two together, I then will get negative 2 over cosecant theta squared minus 1. Now, cosecant squared minus 1, I'm looking at my Pythagorean identities here. If you'll look, cosecant squared minus 1 is cotangent squared. So now what I really have is negative 2 over cotangent squared. And now lastly, if I have 2 over cotangent squared, that's really the same thing as negative 2 tangent squared, because tangent is the reciprocal of cotangent, okay? So there we go. And if you don't understand this last step here, let me show it to you like this. You really have negative 2 over 1 times 1 over cotangent squared, right? I mean, if you were to take these two fractions and multiply them back together, you would get this right here, okay? And then 1 over cotangent squared is really tangent squared. And so negative 2 times tangent squared is negative 2 tangent squared, okay? All right, moving on to the next problem, which would be number 68. And now we're moving on to page 610, okay? Page 610. So let me go back here a little bit in my book, and we're going to do 68 and 78, okay? All right, 68 says write this as an algebra expression, okay? So here we go. Well, first of all, understand that I have here sine of theta equals x minus h all over r. Now, I'm going to go ahead and draw my triangle here, okay? And here's theta. Now, opposite over hypotenuse, so opposite would be x minus h, and hypotenuse would be r. So using Pythagorean's theorem, I'm now going to solve for this. I'm going to solve for this leg right here, okay? This leg. And so here we go. Leg squared plus leg squared equals hypotenuse squared. Well, I'm not going to do a lot of work for you because you're pre-cal students, but x minus h times x minus h would give me x squared minus 2xh plus h squared equals r squared, okay? Now, if I bring all of this over right here, what I'm going to have next is this. L squared equals R squared minus X squared plus 2xh minus h squared. Okay? And then we take the square root of both sides. Okay? So the square root of this would be, and to be honest with you students, probably what I should have done is just left this x minus h quantity squared and brought that over to the other side and made it negative, okay? And just left it in the parentheses. That's okay. We'll leave it like this for now. So what I have is the square root of r squared minus x squared plus 2xh minus h squared, okay? Which is okay, no big deal. Now, I'm going to pick all of this up here and move that from my leg right up here, okay? So there we go. Now, having done all of that, now what they want us to do is they want us to find the cosine, okay? The cosine of theta. So we took this whole expression here and we wrote it with theta. Then we wrote it again with a triangle, okay? Now I'm going to take the cosine of theta. So the cosine of theta would be adjacent over hypotenuse. So my final answer, the cosine of theta would be r squared minus x squared plus 2xh minus h squared all over r. And there we go. Now that's an algebra expression that represents this original expression right here, okay? So there we go. Okay, moving on to number 78. Number 78. Okay, students, here we go. Last problem on the review sheet, and we're finished. Okay, so here we go. First of all, it's totally okay if you want to put y for g of t. I have no problem with that. So I'm going to go ahead and put y equals arc cosine of t plus 2, okay? Now next, remember, usually you rewrite your arc cosine with a theta, but because the entire arc cosine equals y, we're going to rewrite it like this. Instead of putting cosine theta, we're going to put cosine y equals t plus 2, okay? So that's the first thing you want to do. The first thing you want to do, students, is rewrite your arc cosine so that it looks like this, okay? Now, next, what you want to do is, let's go ahead and get a table of values set up here. Usually it's x and y, but in this case, it's going to be t and y, which is totally fine, no big deal. So when we graph this, instead of having an x and a y axis, we're going to have a t and a y axis, okay? Now, we're going to put values in for y, okay? Now remember, arc cosine means that the angle for cosine has to stay between quadrants 1 and 2. So y has to stay between 0 and 180. Now don't forget that, okay? It's very important because it tells us what to put in over here for y. So for y, I'm going to put 0, and then I'm kind of going to go in the middle of the middle, I guess. 45, then 90, then 45 more would be 135, and then 180. And that's good enough, okay? Now, it's okay to have decimals over here because we really want to have whole numbers or decimals to help us graph this later. So I'm going to grab my calculator real quick, and I'm going to put a 0 in for y, okay? So the cosine of 0 is 1. So the cosine, the cosine of 0 right here is 1. So I have 1 equals t plus 2. Now bring the 2 over, make it a negative 2, and you get negative 1 equals t. So there's t. When y is 0, t is negative 1. Or you can say when t is negative 1, y is 0. Now let's put 45. Now let's put 45 degrees in for y. So 45 degrees right here, okay? So the cosine of 45 degrees would be 0.71 rounded. So 0.71 equals t plus 2. Then bring the 2 over, make it a negative 2, and you get negative 1.29 equals t. Okay? So there we go. So when t is negative 1.29, y is 45 degrees. All right? Now, next, let's put 90 degrees in for y. So we'll put a 90 here. All right? And the cosine of 90 would be, let's see, cosine of 90 is 0. So I have 0 equals t plus 2. Bring the 2 over, make it a negative 2. So I have negative 2 equals t. So there we go. When t is negative 2, y is 90. Now let's go ahead and put 135 in for y. And let's see what we get here. Cosine of 135 would be, all right, let's see. Cosine of 135 is negative 0.71 equals t plus 2. Now bring the 2 over, make it a negative 2, and you get negative 2.71 equals t. All right. And now lastly, we're going to put 180 degrees in for y. Okay. 180, like this. And the cosine of 180 is negative 1, excuse me. So negative 1 equals t plus 2. Now bring the 2 over, make it a negative 2, and you get negative 3 equals t. All right? So there we go. We got 5 points we can pretty well plot here. Okay? So let's quickly see. On my t-axis, I'm going to range from negative 1 to negative 3. So I'm going to space that out pretty good. Here's negative 1, negative 2, negative 3. On my y-axis, I'm going to range from 0 to 180, so one, 2, 3, 4, 5. So we'll say 0, and then 45, and then 90, and then 135, and then 180. And here we go. Our first order pair is negative 1, 0. So we'll plot this in green right here. And my next order pair is over negative 1.29, so about right here, and then up 45. My next order pair is negative 290, so over 2, and then up 90, okay? My next order pair is negative 2.71, so about right here, and then up to 135, so about right here. And then my last ordered pair is negative 3, 180, so about up to here. Now, it looks like it's a straight line, but it's really not, students. Remember, an arc cosine graph is going to have a curve to it, something like this probably, then here, and hold on one second. It would look more like this. From here, it would come here and curve a little, and then go like this. And then from here, it would curve a little like this, and then go like this. On a test or a quiz, would I expect you to remember there's a curve in it? Yes, I would. And that's just because you should be very familiar with the cosine or the arc cosine function graphs, okay? But yes, I would expect you to know that, okay? But anyways, that's how you graph that, okay? I hope this review sheet part 2 has been a help to you guys. I do apologize for my voice being so bad. If you have any questions, don't hesitate to call or email.